I want to simplify the square root of a secant quantity squared minus a squared. First, we're going to distribute the square. So the square has to go on both the a and the secant. So that's going to be a squared times secant squared minus a squared. Both of these have a factor of a squared, so I'm going to factor that out. And I will be left with secant squared minus 1. One of the Pythagorean identities is tangent squared plus 1 is secant squared. So if I subtract 1 to both sides, I get the tangent squared is secant squared minus 1. And notice that's exactly what I have here. I have secant squared minus 1, so I can replace that with tangent squared. And now I just need to take the square root of everything. So the square root of a squared is a, the square root of tangent squared is tangent. So you can kind of think of this as a tangent squared and then taking the square root of all that. So whenever you're taking a square root in general of something squared, it's always going to be the absolute value of x, because you always want to make sure this value x is positive. And the reason is because whenever you have a square root function, the square root function is always going to be greater than or equal to 0. So let's say if you had square root of negative 3 squared, if I said this was negative 3, well, notice that the square root of x is never negative. Okay, so that's why we have to put an absolute value to make it positive. So similarly here, we'll take the absolute value, and then the square root will cancel, and I'm going to have the absolute value of a times tangent theta. So that is in simplified form.